You know, we're all obsessed with making AI more accurate, safer, and more helpful. But how do we actually check its work, especially at a massive scale? What if the best way to evaluate an AI is with another AI? Today, we're diving into the pretty wild world of the AI that judges other AI. I mean, think about it this way. Every single time you ask a large language model a question, it's kind of like you're giving it a homework assignment. So how do we grade its answers? Especially when you're talking about millions, maybe billions of answers a day? That's the huge question we're tackling here. And that's exactly where we see the rise of what researchers are calling LLM judges. The idea is, well, it's simple but really powerful. Instead of relying on slow, super expensive humans to check every single AI output, we just use a specialized AI to do the grading. This is an absolutely critical step in making AI better, safer, and, more aligned with what we actually want it to do.
So what exactly is an LLM judge? Well, it's an AI model whose entire job is to look at a prompt, see what another AI said in response, and then give it a score. Is it right? Is it safe? Did it even follow the instructions? These judges are quickly becoming the go-to, scalable way to do this in the world of AI development. But there's a pretty big catch.
Yeah, it turns out that even these brilliant AI judges have a massive blind spot. While they are absolute masters of language and reasoning, they totally fall apart on tasks that seem, well, surprisingly simple. Tasks that go beyond just understanding text.
Okay, so take this prompt from a recent research paper. Seems totally straightforward, right? It asks for a poem about eucalyptus trees, but it includes one very specific, very verifiable rule. The poem has to be at least 350 words long. Now, this is where things get really interesting.
And bam! This is where the weakness is totally exposed. A standard, text-only judge looks at a poem that's only 321 words long and gets it completely wrong. It basically just makes up a reason, saying, yep, looks good, it meets the 350-word requirement. But a new kind of judge, one that has access to tools, does something totally different. It just whips up a tiny bit of code to count the words, gets the right answer, 321, and correctly fails the response.
And this just lays the core problem bare, right? For all their incredible power with language, these text-only models are not calculators. When it comes to something that needs a precise calculation, like counting words, they're really just guessing. And as we just saw, they often guess wrong. So, what's the fix?
Well, the solution is actually super elegant and really, really powerful. Instead of trying to force a language model to be better at math, you just give it a calculator. Or to be more accurate, you give it a whole toolbox. This right here is the big aha moment in AI evaluation. This whole approach is called Tool Integrated Reasoning, or TIR for short. All it means is that we allow the AI judge to call on outside tools, in this case, a secure code executor, anytime it needs to check a fact. It doesn't have to guess the word count anymore. It can just run a quick script and know the answer for sure.
Okay, so here's how it actually works, in a simple four-step loop. First, the judge thinks about the problem. Then, when it hits a fact that can be checked, it writes a little piece of code. A secure interpreter runs that code and feeds the answer back to the judge. And finally, the judge uses that verified info to adjust its thinking and deliver a way more accurate final judgment. Simple as that.
All right, so we've given our judge a toolbox. Awesome. But how does it actually learn to use those tools? I mean, a hammer isn't much good if you don't know how to swing it. This is where some really clever training methods come into the picture.
So the researchers tried out two different ways to do this. The first one, they call TIR-Judge Distill, is kind of like an apprenticeship. The judge learned by watching a bigger, more powerful teacher model use the tools the right way. But the second path. Now this is where it gets really fascinating. They call it TIR-Judge Zero, and it gets no teacher at all. It learns everything on its own through trial and error. And what's amazing is that the research found it performs just as well. It proves these models can actually teach themselves to be better judges.
Okay, so the big question is, does all this actually work? Does this new judge with its fancy toolbox really perform any better? Let's take a look at the data, because honestly, the results are pretty darn impressive.
So, when you put it up against other strong AI judges that only use text to reason, this new TIR judge shows a huge performance boost. In head-to-head tests, where the judge has to pick the better of two answers, it saw gains of up to 7.7%. In this world, that is a massive jump in accuracy.
But wait, this next number is the real showstopper.
A relatively small 8 billion parameter TIR-Judge managed to achieve 96% of the performance of the absolutely massive Claude Opus 4 model on a key test. What that means is you're getting top-tier performance from a way smaller, way more efficient model. That's a huge deal.
And look at this head-to-head comparison on the PPE benchmark, which is all about correctness. The self-taught TR-Judge 0 hit 76.6% accuracy. You compare that to other models of a similar size, and it's crushing them by about 10 full points. That's not just a win, that's a blowout. It's clear proof that giving judges tools really works.
Okay, so this is all really cool from a research standpoint, but what does it actually mean for you and me? Why should we care about having better AI judges outside of a computer science lab?
Well, you got to understand the ripple effect here is just enormous. More accurate, automated checks mean we can build safer AI because we can actually find the problems. It means our digital assistants are going to get way more reliable and actually follow instructions precisely. The whole development cycle gets faster, and it all boils down to building a foundation for AI systems that we can actually genuinely trust.
And all of this kind of leads to one last big question. We are building an AI that can check its own work with provable computational accuracy. So as we get closer and closer to that goal, and AI can judge itself perfectly, what's going to be left for us to judge?